Thank you everyone and welcome back. I am back with my series of webinar under the umbrella of Igniting Power Engineers. Before I start and invite the special presenter of today, I would like to thank Almighty, my family, my mentors, my friends, and my good wishes. Because what I feel without these people, this journey wouldn't have been possible. A few names include respected Wahi sir, N.K. Mittal sir, K.K. Murthy ji, S. Pao sir, K.K. Gupta ji, S.K. Batra ji, Sanjay Agarwal ji, my friends Saket, Rakesh, Pradeep Garg ji, who just pushing me, supporting me every day, every time. My team behind the scene, Gulab and Ram Dhani. Now, time to give a brief introduction of today's presenter, a very special guest, Dr. Vikas Almadi, the CEO and the director of DEN India. I can say proudly that he's the right epitome of a person, how to live grounded, because what I feel you can with your talent, you can reach to a particular position. But how long will you be there? That is decided by your behavior and attitude. And he's well-grounded person, good friend of mine. DEN is well known, or rather I should say pioneer and leading company worldwide in lightning and surge protection. This company has brought lightning and surge protection to a next level to save lives and equipment as per the IEC standards. Vikas is a person with rich experience of more than 25 years experience in the field of surge and lightning protection. Under his guidance, the company has crossed many barriers and brought new products, as he's a passionate person, loves to do R&D in finding new and cost-effective solutions for the Indian market. Now, without wasting any time, I would like to hand over to the special guest, Dr. Vikas, to start the presentation. Welcome to the show, sir.
Jai Hind hai, good evening, namaskar, everyone. Rajesh ji, आपको सभी को, सभी seniors को, as I can see there on the screen, and all the organizers. So thank you very much for inviting, first of all, and thanks for giving me the opportunity to talk about this subject again. And this subject again is always a new subject, and thanks for understanding the need of this subject and asking me to come and present here. Thank you very much, and it's a blessing of all of you that we are learning on everyday basis. Is a 24/7 students basically we are, and if any mistake is there, please feel free to correct us. We'll be happy to listen to the corrections also. So I will share my slides actually because the time is very important, and here you see my screen there actually, and let me don't worry about the number of slides that you see here, but we will start from the beginning. So Rajesh ji, just confirm me, you can see the first one slide or two slides actually, just
no, still there is no slide.
Okay, but from my side it is shared.
So it's not showing.
Okay, I do it again.
Can you do it again?
Yeah, I reshare it, please.
Now it's working. It's working fine, sir.
It's working fine?
Yeah.
Okay.
You can make it full screen.
Yeah, that's what I'm trying to make again.
Yeah, perfect. Very perfect.
It's one screen now or two screens?
One screen.
Very good. So even though we tried during the day, but still, at the time of seminar, something still happens. Fortunately, it didn't take more than 10 seconds. Good. So should I keep my camera again on? Of course, this will be good for me, and if some of you can also keep your cameras on, it will be good to see some of you is there. Yes, so we are talking about the surge protection for continuity of the services, and my name is Vikas Almadi. As Rajesh has given very nice introduction, thanks for the nice words, Rajesh, that you used. I am heading DEN in India for last 11 years, but associated with DEN for last more than 25 years now, and of course, associated with this subject since my childhood, which is lighting protection, surge protection. So today we are not going to talk about lightning at all. Lightning will be a part of surge today. Earlier, basically, what we used to do was surge was a part of light. So maybe a little bit of twist, and it will be nice that you can suggest at the end, ask the questions at the end as to how was the seminar and what is exactly you want more in details, so that we can cover in the coming seminars if opportunity is given to me. So this is 1 hour, and 1 hour is about the surge protection. So we talk about surge protection, need of the surge protection, and designing of a surge protection device for low voltage power systems actually. So even if we are able to do in 1 hour, I will see that it will be good efficiency of all of us. So beside this, it is showing the company headquarters, the photo of headquarters, which has recently been shifted to a new place. Now, when we talk about the services, surge protection is important for the services because services are important for us. And services means anything that we use nowadays, the buildings, our homes, our data, telephone, our transportation system, be it railways, metro railways, or whatever, airplanes. Then process industry, we need fuel, we need maybe in future hydrogen, or we still get the gas. If we get the gas, I'm not going for geopolitical questions right now. And industries, all the automation is industry 4, industry 3, everything is already going on, and industry 4 is talking about more about IoT, etc. Then we are talking about the renewable energy of various forms, whether it is wind or it's renewable. Decarbonization is a topic which everybody talks about. Not only that, we have other such topics to talk about, talking about pure water at home or clean water at home. This is again a topic, and that again needs equipment. Then surveillance system, security is a big topic. Defense also is a big topic. Fire alarms are a big topic, where if they are required at any given time, they should be available. So we are talking about all the services where we can't imagine any downtime in these, including the power stations. Like when we talk about the power itself, power should not go off. So we want 24/7 availability of these services with the uptime of 99.9999 many nines percent, which is almost 100% actually. This is the expectation. And the other side, we have topics like, as I mentioned, digitization, carbon neutrality, 5G, more and more electronics will be adopted for achieving these goals. That means more and more pollution will go into the grids. And we are talking about generators and substations also, how to protect, how to make sure that all the services which are provided by them, basically the electricity is the service there, which should be 24/7 available. Unfortunately, power is not always good, and some noise in the power or some pollution in the power creates some kind of damages. Some of the damages are visible, and as engineers, I would not say any of us or none of us, or we'll not be having anyone out of us who has not seen any damage in his life. So we have seen PCBs burning, we have seen big equipment burning, cable burnings, and things like that happen. It is not that the fault is always visible. You cannot relate to an immediate incident. Sometimes it just fails actually. Nobody knows why. And that becomes more critical for us or engineers to verify or to analyze where exactly was the fault. Then, of course, when we go to the power quality analysis and all, then we find out there are something still more than what analyzers are showing. When we talk about power quality, basic, very famous wave shape, which we all have seen since our, I would say, professional childhood or education childhood, I would say. Voltage into current, that is the product of voltage and current is power. Everybody knows that. And also, when we talk about power quality, we talk about voltage quality, and we talk also about the current quality. That is what will be power quality. On the other side, energy. Energy is more about usage of power with time. How much power we are using for how much time, or we are producing. power generated or power consumed with time. So it is a kind of integration of these three parameters where time factor comes into the play. When we talk about time factor, there is a rotation factor also, and here frequency of 50 hertz is assigned to the wave shape that we use here in India. In other countries like US or so, we have 60 hertz there. That means rotation of the cycle is 50 cycles per second. On US, it is 60 cycles per second. Some application is 16.3 also, particularly in some railway applications, and we have 25 cycles also in some AC lines all over the world. These different kind of frequencies are used, but for power it is 50 hertz, 60 hertz. We are talking about per second here. My point is not to talk about the various frequencies here. My point is to talk about the time that we are talking. Time is just milliseconds. 20 millisecond we have full cycle covered. Now this is a picture I have taken from somewhere. I don't know from where. Basically, this is not done by me. So you see that when we talk about time, the disturbance in the power quality is also defined not only based on the amplitude but based on the time. High frequency, low frequency, very high frequency. And we are talking today about this first portion here. Very first portion, not all. That too in 1 hour. So we are talking about the transient impulses, surges, which are in the range of microseconds. Or maybe we can extend little bit into short durations, but this is too long for surges or so. 1 second is like infinite or eternity for research. Basically, surge is a microsecond phenomenon. Micro, 10 raised to power minus 6 of a second. So much small time we are talking about today. And you can imagine what part of the sine wave we are talking about today. Too minute, but it kills. So when we talk about surges, there are different regions of surges. There are different sources of the surges. And here we have, of course, lightning is a big source of a big surge, which is called impulse. And the rating of this impulse is given as 10 by 350 microsecond. Many of you already know what is 10 by 350. If you do not know, I will cover this because I feel that it is still important. Every seminar you can ask me about this. This is important to understand what is 10 by 350, what is it better. It's about microsecond again. Please keep your eye on the time, on the waveform, of course, on the watch too. So when we talk about indirect lightning, that lightning has taken place somewhere else, but the effect of this lightning is seen in our premises as an inductive effect or a capacitive effect, but in the form of some surges which are appearing on the line. And surges themselves are due to the switching operations, heavy loads, inductive loads, capacitive loads. When they switch on or off, it may be there in your premises or it may be out of your premises, connected to nearby thing. Switching on of motors, short circuit faults, earth faults, tripping of even the fuses, and parallel installation of power supply and IT conductor systems. IT is your information technology I'm talking about, not the IT system of electricity. All these systems, they form kind of loops, and the current flowing in these loops cause the surges, and switching effect itself is a kind of absorbing and releasing of energy that is also appearing in the form of surges. So some are big surges, some are small surges. Big surges are like lightning kind of thing where we have giving the grade to 10 by 350 microsecond, and the small surges are rated to 8 by 20 microsecond. So what is 8 by 20? What was 10 by 350? Maybe those who are curious, it is important to know about these two wave shapes again, and it is very important to please know about it. Here, the green wave, if you see, and the red wave, there are two waves. On the x-axis, you have time in microsecond. On the y-axis, you have current in kilo amperes multiplied by 1000. That means we are talking about here 100,000, 1 lakh amperes of current. So current can vary and it can change for with the source and the intensity. Now if you see the duration also changes, but the major difference is the green wave is rising in 10 microsecond to its top value, and it drops down to half of its peak value in 350 microsecond. So 10 microsecond is the rise time, and 350 microsecond is the time to half. So that is why this wave is known as 10 by 350 microsecond wave, because of the timing, not because of the current. Similarly, the red wave, which is smaller one, it rises in 8 microsecond and comes back in 20 microsecond. And it is also seen that the amplitude of this wave cannot go very high. It is limited to maximum 20 kiloampere. So and the green wave can go up to 200 to 50 kiloamperes. So whatever is shown here, there is the examples, and you can see that the area under these curves, whether it's a green wave, if you see the area under the curve, it is integral of I square into t, and I square into t is nothing but energy, and that energy represents the area represents the energy. Here you see that the area of green wave is much higher or much larger than the area of the red wave. So that means we are differentiating these two waves not only in terms of time, but in terms of the energy content also. We say big or small. Big is big area, small is small area. Big is 10 by 350, small is 8 by 20. So when we talk about lightning, we talk about 10 by 350 always. When we talk about surge, we talk about 8 by 20 microseconds. Lightning can be source of surge. Right? And here we have to see that in both the cases, the rate of change of current, di by dt, is very, very high. So the factors which can influence di by dt or which can be influenced by di by dt are the length of the cables. If the length of the cables are long, then L di by dt, which forms the voltage, will also be high. So these phenomena are to be seen differently, not in the way as we are looking at 50 hertz or a DC hertz. No, 50 hertz and DC, a connection means a connection. Whereas in this case, connection at one point may not be a short at other time, because the length in between creates a hole there. So that is why, when you're making for example, earthing system also, you're making a grid of that. So if you don't make the grid, there will be effect of LDI by dt too, apart from other things. So all this is not being drawn by me. These are all mentioned in IC standards, which are adopted in IS standards. Many of us, they know about 2309 standard, which have been abolished, and new standards are IEC 62305 since 2016, not new. And the energy in content in this microsecond is tune of 2.5 megajoules per ohm. So the kind of resistance that these are going to see, and that kind of heating can be produced by these kind of waves. So these are looking small but dangerous kind of voices. So when these kind of waves flow into a building where you are having IT system and also power supply system, which is normally there in all the buildings now. Even the substation now is getting digitized. So you have IT system and you have power system. And similarly in all the industries, all the process companies, even our homes, now home automation, Ethernet and all, we have these two wiring minimally done. So let us say when the lightning strikes on such kind of building, then what happens? Then you have lot of current flowing with high di by dt over the lens, and there are some parallel lines which are coming from the other sector or IT sector, I would say. And that is where you see the coupling of the energy due to the interference between one kind of power supply to the other one, and these coupling is seen in terms of voltage. So suppose you are like, this is the internet I am using to deliver you the presentation, and you don't want the presentation to be interrupted. So I would see that my IT system is perfect, and backend Reliance or Airtel, their IT system is also perfect. And if there is a nearby strike, then of course there will be some influence of this on the building side. So just to know one more line about the lightning thing, because this is important, is the highest surge in terms of the capacity or timing. When a lightning strikes on any building, it creates a surge, and how much of this flows through our lines, be it power line or metal pipeline or telecommunication ratio is 50 and 50. 50% only goes to the earth and 50% goes to a good power system, metal pipeline, or telecommunication system. So those who are believing that a good earthing can solve all the problem, consider these calculations which have come up after so many experiments worldwide, and IEC has adopted this formula for division of lightning current. So that means this much of surge is expected on the power line or telecommunication line based on their resistance. Of course, it will be divided and we have to take the measures accordingly. Now the equipment that we use, let us go inside the equipment a little bit. Basically, most of our electronics or most of our automation system, wherever we use, they are low voltage systems. And how do they work actually? Let us talk about this. So inside of any electronic system, first component is a power supply. Inside or outside, it depends. Even your computer basically has a power supply at the end. So just to make it a little simple, that any electronic component will need a power supply, and power supply can be inbuilt or output, but power supply is there. And this is the circuit normally that is used for power supply, because normally the power supplies are SMPS power supplies, and they have IGBTs or MOSFETs, which are switching at a very, very high frequency. I'm not going to talk about what is the effect of those high frequencies on the network, and that is how basically this kind of big filters are being used to suppress those kind of noises which are created by SMPS. And SMPS is everywhere, even in the renewable, windmill, solar, everywhere SMPS is there. Maybe we can cover another session where we can tell what are the effects which are going to be there due to more and more use of electronics in grid integration, and what are the threats and how it can be mitigated. That is a totally separate subject. We'll take it later. But just to have a small understanding of this, SMPS from inside, it has a suppressor and then the circuit like MOSFET. Suppressor is nothing but it is a small blue color device you will see, or sometimes it is brown also. This is called MOV. You open any circuit, basically you will find it sitting there, somewhere at the entry level, somewhere at the output level, because it is something which is trying to protect. It can absorb energy of 151 joules. If input surge is there and this is trying to travel to your main input point, it will absorb up to 151 joules. This is a data sheet of extract of data sheet from EPCOS, Siemens company, one of the best, 151 joules. Now you have seen that in case of lightning, we are talking about megajoules there, and it can carry a wave shape of 8 by 20 microsecond. It dissipates the energy, it heats, and every time it leaks, it's a kind of variable resistance. More voltage you apply across this, that means that if the impulse is increasing, this will have low resistance. So every time there is a voltage exposure to this device will get aged. The performance next time will not be the same. It will be deteriorated. That means it will die out sometime because it is having aging effect. And then every time there is a leakage of the current. Some microampere can go up to milliampere and maybe higher. You know that, like in your lines, you are also using LAs. LAs is a big MOVs, you can say like that. They have leakage and you're monitoring the leakage to check whether the LA is still healthy or not. But inside the power supply, nobody checks it, and nobody can check it also. And you could see that when it is exposed to the surges or lightning, which are much higher than the energy that it can dissipate, it bursts, and that is what actually creates most of the failures. But sometimes it can withstand that. So it is not that every surge is killing surge. So there are different type of surges. You see, there are, like, this is a band that our system works in. Some of you might have already seen it. So some surges are in the safe area, so no worries about that. But every time there is a degradation, that is sure. So degradation can be within range or can be still higher. So some surges will not show any immediate result, that means immediate failure, but it has degraded, or these have degraded the, and some will further extend this range and they will show a catastrophic failure, and you will find that basically the equipment has immediately failed. Something has come in, equipment has immediately failed. Many of us have observed such kind of events too. So when we talk about bigger subjects lighting protection, then surge protection is a part of it. That's why I'm showing these standards to you. That surge protection is a part of it. Without surge protection, even lighting protection cannot also take place. So this is important part, and this cannot be omitted. Whereas when we talk about lightning, we are talking about very high currents of up to 200 kiloamperes in class 1 or up to 100 kiloampere in class 3 and class 4. Again, you have to see when I talk about lightning, automatically I talk about this wave shape 10 by 350, which is known as impulse. So difference between lightning and surge is 10 by 350 and 8 by 20. Lightning means impulse, surge means over voltage in surge protection category. So when I talk about surge protection, then basically you have to consider big and small both kind of surges which can disrupt the services. And even if you see the standards 62305 are the same are the standards, they talk very clearly about the coordinated SPD system, which many of us are avoiding. And with the structure which is having lightning protection, good or bad, doesn't matter. It has to have a class 1 SPD. This is a requirement actually. Why it is a requirement, you will see. And you just imagine maybe your substations or maybe your own industry where you're working. Just imagine any of your power panel or any of your IT panel. You try to relate it basically. That will be easier for all of us to understand the things. So here basically you have a current which will potential across the earth. Everybody knows that a fault current creates a GPR, and this GPR creates a potential difference, which then creates a big current, and this current is depending upon this strike. And there could be the current coming as a surge also inside the equipment bidirectional. And what we have to do is we have to give a path to this current so that this voltage difference is not there. So we cannot short line an earth, we cannot short line a neutral. We have to create equipotential bonding. Everybody knows about equipotential bonding, but let me tell you again. Like in case of lightning or in case of surge, there is the phenomena that takes place is it is on one side your potential becomes very high, on the other side the potential remains low. So when this potential difference is there, the current will flow from high potential to low potential. And this potential difference, if it is appearing across the device, it will break the insulation of the device and flow through the PCBs or through or like a arc. So in order to avoid the failure of this equipment, you need to bypass this current. Bypassing the current or equalizing the voltage is one and the same thing. So you need to have a switch-like arrangement, which is normally off because you cannot connect line and neutral and earth together. Normally off. In case of surges, it will turn on, and then when it turns on, the other side also get the same voltage. That means on the equipment side, you don't see any change or any difference in the voltage. So no current will flow from the equipment. Current which would flow through the equipment will now flow through the switch, and this switch is nothing but the SPD. If this is rated for 10 by 350, it is known as lightning current arrestor. If it is rated for 8 by 20 microsecond, it is known as surge arrestor. So SPD is creating a equipotential bonding, and without the SPD, even lighting protection is not complete because it will still kill the equipment. So SPD becomes a part of the lighting protection also. This is important to understand. Without SPD, the comprehensive lighting protection is not complete. That means everything in our building or our infrastructure, everything should be at same potential when there is a lightning strike. The live conductors, which we cannot connect directly to each other or to earth, we have to connect them via the SPDs, which are normally in the off condition. That means normally they are creating the isolation, but when there is a surge or lightning, they are creating equipotential bonding. So everything has the same potential. There is no possibility of arc. There is no possibility of any fault current flowing from the equipment. Equipment is protected, services are protected. That is the basic principle. Equal potential bonding. Equipotential bonding. Everything at the same potential. In order to do that, bond it together. Bonding cannot be done by live wire sometimes because of the different voltages there like line, neutral, and earth. So we have to connect them via the SPDs, which act like switches. Simple. So here, use of SPD equalizes the potential of the conductors, enhances the safety, and reduces the chances of dangerous sparking in the building. This is a fact, and you can see this, how the current would flow if there is a panel like this, and like some of you are into process industry, where basically long lengths of cables are there, and sometimes the earths are also kept separate, right? So in case of normally if there's 0 volt is there is no problem. That means there is no fault, no problem. When there is a fault like lightning or any surge, then one of the earth will get a ground potential rise. That means the potential will rise from whatever normal voltage, like let us say 0, to some kVs, and this will appear across the field sensors, and then it will travel to the main control panels and try to go to the earth, but from there also it will still go to the other earth. So the looping will start. So this is phenomena which is the natural phenomena, and everything red here will get the damage. You see, depending upon the insulation, basically the things will start getting damaged. But when we protect it via a bypass path like this, the current is not flowing through the main devices. In this case, current may be flowing still through the cables and through the earth and through the main transformer earth, but it will not flow through the equipment which are used for operation. So since this portion of the circuit will still be carrying the lightning, there is a possibility of surges which can be still protected by surge protection devices. So here you see this kind of isolation or this kind of bypassing is achieved by using this kind of switches which are nothing but the SPDs. So SPD bypass this lightning current. Lightning current is anyway going to flow. It should not flow from our equipment or our devices, our sensors. It should bypass through them and pass through the SPDs. Now when we talk about SPDs, and also there must be a question that of course one of the reason that why we should not have two earths is this too, apart from the human safety, because that is the prime reason of having one earth. But if you connect the earth together, that is the best situation, because then you reduce the level of current which is flowing through the SPD or through the equipment there, and it then depends upon the resistance and the length of the cables here, because as I mentioned, length of the cable plays a role. So there will be still some current going which may still lower down, and it can even help us to reduce the capacity of the SPDs also there. So what is the protection criteria for this? This is important to know. How does SPD actually protect? It is not always on. So that means suppose there is a surge here. So surge will try to go inside the equipment. But by the time SPD should come into the picture and divert all the surge. This is how the SPD should work. Now, if it is not there, then all the surge will go here. But if the SPD is there, then of course it will try to divert. Diversion is possible when SPD is in parallel. So first thing that you get is SPD is in shunt with the equipment. That is the first takeaway from this. Now, when SPD diverts the energy, there will be possibility that there will be some voltage across this cable too, across the SPD too, because I mentioned reliability is a very important thing, and length of the cables are also very important, how you are connecting the SPD with the shortest possible lengths. But still, whatever is the voltage appearing in this circuit, same voltage will appear here. Now, equipment can withstand, let us say, a equipment which is having 2 kV of insulation. The voltage defined, or surge voltage defined for such an equipment is 1.5 kV by IC. So I can show you the chart also. So the voltage should be less than 1.5 kV, even if the surge is there of whatever intensity. So if we are able to maintain it less than 1.5 kV, and we are able to limit the current and the timing from the equipment for this surge to flow, V into I into T, then of course we are able to protect the equipment. So final voltage protection level should be 1.5 kV. So we use some arrestor here. If one arrestor is not sufficient, then we try to parallel it with a lower capacity arrestor. We will come to that, but at the same time, we must look at this. Here I'm talking about the low voltage system here, 44V, and IC60364, 534, and this is the chart which talks about 1.55 kV is the voltage we have to maintain, and if we are able to maintain that, then the performance is good. That means the equipment will not be exposed to a dangerous voltage, will be less than that. Or higher voltages, higher voltage equipment, basically higher voltage protection levels are also allowed. So voltage protection level is the voltage that goes inside the equipment, that is allowed by the SPDs to go inside the equipment. So this should be as low as possible. So these are the maximum limits. So when we talk about this topic, not only the voltage, as I mentioned, the current also is flowing through the equipment when the voltage is there. So voltage, current, and the time of flow of this current all matters, and it should not exceed 151 joule. You remember 151 joule is the rating of those MOVs. So if the 151 joule figure is exceeded, even though the voltage is same, your system will still fail. So we have to see carefully that what arrestor we are using here, it is not a showpiece, it is something which actually protects the equipment at the end. Final aim is achieved. So this part is already known to you now, not to repeat it again, but I will like to show you one video here where it will differentiate between the two waves very clearly, because it is very important to understand 10 by 350 and 8 by 20. And you will come across many products which are saying very high currents or so. They don't talk about this wave shapes. Wave shapes are more important than the current. Basically, this is something which I will like to show here. What I'm going to show here is to you is there are two waves, both are at 40 kV. I've shown you the maximum currents, 100 kiloampere, 20 and all. So both are here, let us say, at 40 kiloampere. Wave 1 and wave 2, that is lightning and surge, or 10 by 350 or 8 by 20. This longer wave here, the red wave is 10 by 350 wave, and the green wave is smaller energy wave, is 8 by 20. So let me take you to this video. I've done a wiring test on the lab here. Maybe just a minute. Rajesh, can you see this?
Yeah.
So this was, do you see this? Maybe I started from the beginning here. This is 8 by 20, 40 kiloampere. So we are putting to a wire. Actually, this is the wire here, you see. And some movement in the wire because current brings some force, but no damage actually. Now you see 10 by 350, same 40 kiloampere with 10 by 350. What happens? Same wire. Looks amazing here actually. So same current, but two different wave shape. So it is the timing that was creating the difference, not the current actually. That is very important to be seen. So next time when you come across any device which says that this kiloampere and all, ask the simple question, please tell the wave shape actually. Otherwise, one may end up having a product which may not still fit to the requirements. Okay, so that is the reason there are two types of SPDs now. One type is type 1 SPD, which is rated for 10 by 350 microsecond, and other SPD is rated for 8 by 20 microsecond. When we talk about 10 by 350 microsecond SPDs, second one which is mentioned here, actually, they are rated for 10 by 350 and they are known as type 1 SPDs. Normally, people use spar gap here because spar gap are more rugged than any dissipating devices like MOVs or so. Some people are using MOVs, but at the same time, more data has to be asked. So spark gap is a kind of switch which creates a diversion path. Switch means short. Short means equipotential bonding. So for lighting purpose spark gap and for surge purpose, which is a residual part, can be a MOV or can be again a spark gap. So spark gaps are used for both the application, where MOVs are used only for one application, ideal case. Now talking about the class 1 protection, it has to be at the entry level. Like your dust mat, you will put major dust mat at the entry level of your home so that most of the dust is outside. So it is in the mains panel and it is protecting all the installation throughout after the panel. So it is not only for the meter or not only for the panel, it is protecting everything which is behind the panel. Now question is, if one is sufficient for the building, most of the cases can be one, like small villa houses or so, it is one, it is sufficient. But for industrial cases, basically there may be requirement of more than one also, depending upon the length of the cable. Because I mentioned length of the cable create a oscillatory waves inside because of the DFIDT case, and distance between the point of installation of SPD and the second target equipment also matters. So that also gives us a clue whether we need another SPD or not. How the SPDs are installed? SPDs are installed like this, basically, where you have in parallel to the equipment, this side is the equipment, and line to neutral, each line to neutral, there are 3 SPDs, and 1 SPD is between the neutral to earth. So all are spark gaps, there is no leakage here from line, neutral to earth, there is no leakage at all. So no possibility of aging and no damages, mechanical devices, no problem of the voltages and all. Now, as I told you, I will tell you the designing of this. Very 10 by 350, 8 by 20, you have already understood. And second thing is, let us say the total lightning is 200 kiloampere. 50% of that goes to ground. Balance 50% is for the power line. Because out of this 100 kiloampere which is left out, most of this will go into the power line because of the conductors, very good conductors of the power line. Metal pipelines, IT lines, they will have the current. It's not that they will have zero current, but very, very less, like 1 kiloampere, 1.5 kiloampere. Otherwise, the cable that themselves will not be able to withstand those currents. So here you see the current 50%, that is 100 kiloampere, will try to go through this arrestor. So this arrestor has to be rated for 100 kiloampere, not to forget 10 by 350 microsecond. And after that, this current will divide into 3 lines and neutral. That means divide by 4. So each line will have 25 kiloampere of current, and 25 kiloampere of current will flow through the neutral. So each arrestor that is used at the lines will not be 1/3, but 1/4 of the rating of the neutral to earth arrestor. So that is why you see that all the arrestor manufacturer, they are making line to neutral arrestor for the rating 25, 30 kiloampere, and neutral to earth SPD is always for the higher capacity, which is 100 kiloampere. Thumb rule is divide by 4. Simple, because there are 4 lines. Now for type 2 SPDs, now we have to talk about 8 by 20 microsecond surge and total current. Let us say if we are using the SPD for 20 kiloampere, same rule, multiply by 4, you have to use the neutral to earth SPD as 80 kiloampere. But if you are using 40 kiloampere as the neutral to earth SPD, then this is divided by 4. 10 kiloampere is sufficient enough, because these two ratings should match. Otherwise, there is no point giving one of higher rating and another of lower rating. This is multiply of 4 because of the wiring, not because of any other mathematics. Simple, 1:4. And once this kind of arrangement is done, this should be able to protect the equipment, provided the voltage protection level is less than 1.5 kV and the energy that goes inside the equipment is less than 150 watt joules. So initially at the entry level, we will use the spark gap, which is going to create a kind of short, and of course this will take maximum part of the lighting through this short, divert it, whatever is left out, you have type 2 arrestors. Now, of course, you may ask me a question later on that these are the SPDs which are installed type 1, type 2, and then this is the equipment. Then why IC talks about the fuses here? Why is this very, very important? Maybe we can cover this in question and answer if somebody is interested to know about it. Otherwise, write an email to me. I will tell about the importance of the fuses. But at the same time, to give you a little glimpse about that, these fuses are very, very important for the safety. You have to consider SPD as equipment which can also fail. Any equipment can fail, SPD can also fail, and it can fail in open condition or short condition. If it fails in the short condition, what happens at that time? If there is no backup arrangement. So backup arrangement can be done by the mains panel itself, but the rating of the fuse, what fits with the SPD well, is defined by the SPD manufacturer. So SPD manufacturer will tell you that what is the rating of the fuse that it needs in the backup. If your initial rating or input rating is higher than the rating specified by the manufacturer, you have to use additional fuses here. Otherwise, there is no need of additional fuses. Now, one more phenomenon. Let us say we are talking about the services here. And when we are talking about the services, we have to talk about the continuity of the services. And let us say this is the service we are providing, and this is the SPD, any type SPD. During lightning, and suppose there is a lightning strike, this will switch it on, and while the SPD is on, there will be a huge current that will flow through the SPD, huge short circuit current, depending upon the transformer, distance of the transformer, etc. So the rating, short circuit rating of the SPD, not only 10/350 rating of the SPD, has also to be seen, and at the main entry level, it has to match with the other switchgear ratings in that panel. Now, if this kind of scenario happens, there is a possibility of failure of the MCB or fuse, or tripping of the fuse. This is not failure, but tripping of the fuse, which can still, cause a discontinuation in the services. So this is also not desired. For that, basically, it is important that to choose the fuses nicely. That is number one, and choose the SPD also nicely, which not only discharges the lightning current, this also limits the short circuit current. Limiting of the short circuit current is very, very important apart from the lightning discharge or current or surge discharge. So here, if the total current which would have flown through the SPD is like this, but SPD has suppression system, so it suppresses the current to this value. That means the overall wave shape of sine will not disturb too much, and load will always be on. So if you suppress this current, which is created by the lightning, operation of the SPDs in the lightning, and since the current is suppressed this time, the fuses will not blow or not trip, and then you will get continuity of the services. So this is a typical arrangement which is to be done. Type 1 SPDs at the mains panel and type 2 SPDs at the sub-distribution panel. Repeat it, and this is how these small components like varistors, as I was showing you, these can be protected, which are the most sensitive one. Hence, all the circuitry can be protected, hence the services can be protected. So this is a typical arrangement now, and before coming to the end of this session, as I promised, I will show you some of the application here. Like this is the control systems of a process industry. Here you see all the lines are protected. It's not only the power line, all the lines which are going to IOs are protected here. Here you will see all the lines going to the cameras in the Ethernet system, CCTV camera, they are protected like this. So that, there will be naturally some potential difference, but you have to neutralize it. You can't catch up with that voltage, or you can't bring that voltage to zero. You have to bring yourself to that level so that potential difference becomes zero. So, and these are some other applications in the panels where the SPDs are used to equalize at the entry level so that there is no disruption in the important services where this power is catering to. So these are some more applications you see here with the larger loads and or CCTV networks. So this is what I was having for today, and it's exactly 6 o'clock basically, and this was the time given to me by Igniting Power Engineers Rajesh Arora, and I think basically I have covered everything in time, and I'm open for questions now, please.
Thank you, sir. Thank you for this mind-blowing presentation, as you are or usually do it's a new thing for Vikas Almadi studies concerned. Thank you once again for this mind-blowing presentation. And before I take the question, I would like to invite, as I usually do, PP Bhai Sahab, kindly unmute yourself and say a few words.
Thank you, sir.
Bhai Sahab, kindly unmute and start.
Hello, Rajesh, are you getting me?
Yes, sir. Please continue.
Yes. Good evening. Good evening, all my friends, and Rajesh ji and Dr. Vikas. Sorry, I could join a little later today, you see, because of some problem in the system. See, it was around 5:30 only. See, I have to congratulate both stalwarts. This is Dr. Rajesh and Dr. Vikas for putting in really a wonderful effort and a wonderful attempt to see that we are put on a really good subject, wonderful subject, research production. You see, normally we have heard a little lesser on this subject in various conferences, but I salute Rajesh. He's always trying to work hard day and night, and I really get amazed sitting at home finding how he does, when does he sleep, when does he take care of his other duties, you see. But anyway, I salute him, and I am proud of him that he's really igniting the power engineers in a very dedicated manner, the role which he started, I think, couple of years back. So honestly, no words with me for
Thank you,
Rajesh,
sir.
because he's doing a wonderful job for all of us, accentuating our knowledge and doing a wonderful job for the nation and other areas.
Thank you, sir.
Coming to Dr. Vikas, I think it is one of the best presentations I could have ever get into.
Thank you.
See, he has made it very, Dr. Vikas, you have done it in a very lucid manner. I've made wonderful slides, tried to make it very simple. And I'm happy to see that you have really given us really fair idea what is the importance of the surge protection, what are the SPDs, how they are connected, what is their role, how many types of SPDs are there, what is the role of the fuse in case there is a failure of SPD. We did not know much about this subject, but I think you have really enlightened us today in this session, and hope in the days to come you will still help us getting more knowledge on this subject and other subjects related to surge protection, lightning protection. So this is a wonderful job you've done today. I have really enjoyed this evening.
Thank you, sir. Thanks very much.
Getting with you and my other friends for this session. Wonderful. All my best wishes to both of you, Dr. Rajesh and Dr. Vikas, both of you. You have
Thank you,
done a
sir.
wonderful job for all of us, and really, God bless you both. Thank you so much. Thank you.
Thank you, sir. Thank you.
Thanks for it.
And now I would like to invite S. Pao, sir. Kindly unmute and say a few words before I start question answer session.
Yeah.
Sakesh ji, kindly unmute Pao, sir.
They can unmute.
Rajeshi, I think he cannot unmute himself. Maybe you'll have to control, please.
Everyone has the access to unmute.
Okay. If there is some technical glitch, we can start the question answer. Kindly raise your hand and one by one we will take the questions and the answer will be given by Dr. Vikas. Kindly unmute one by one.
Can I ask a question, Rajesh?
Yes, welcome to show, sir. Mr. Sir,
Okay,
please.
okay. Thank you very much. First of all, my appreciation for a very nice presentation. You have made it simple in a way that one can understand how equipotentialization can be achieved. Earlier, we used to achieve it by various methods, but the way it is described, all equipments carrying current has a SPD. All non-current carrying equipment does not have a SPD. It is directly connected to the EBB, which
Yes.
is indirectly Earth. So very simple way of making the people understand. Although I do know something about the product earlier, we have been using it for quite some time. 2-3 quick questions, very small questions. You have when we were discussing about the SPD capacity 100 kA.
Mm-hmm.
So the first thing that came to our mind, if there is a lightning strike of 200 kA
Mm-hmm.
and 100 kA goes to the earth and 100 kA comes back to the system.
Mm-hmm.
When it comes back to the system, the SPD is selected in such a way so that it is suitable for 100 kA, means 25 kA per pole.
Sir, yes.
For all the 4 poles. But when you make a pictorial diagram, in the pictorial diagram, it depicts that 25 kA per pole is for the 3 phase to the neutral.
Mm-hmm.
Neutral to the earth is 100 kA.
Yes.
Then why do we call it 100 kA, 25 kA per pole? That is point number 1. This I couldn't understand. Number 1. Number 2, we have SPDs available, as you have rightly said, spark gap and MOV. Fine. MOV basically for 8/20 microsecond curve, and the other one for the 10/350 microsecond curve. But we have SPDs available in the market many times. They call it 3+1 or 4+0.
Mm-hmm.
Many times we are using 4+0 also. So what is the basic difference between 4+0 and 3+1? What are the places where you suggest to use 3+1 or 4+0? Point number 2. Point number 3. The latest NBC code says we have to use SPDs which can withstand, in case of a neutral disconnection, it should be able to withstand 440 volt for at least 2 hours. This is what the code says, NBC 2017. Yeah. The fifth question which I have is, suppose there is a building and ours is a large plant comprising of few buildings, maybe 3, 4, 5, 6 buildings. So every building is to be treated independently in the same fashion, that there could be a lightning strike in any other building. So whatever goes inside has to be, the first point of entry in that has to be protected with 100K system, because there is a possibility of 100K coming back into the system. That is one. Now the second distribution point, the first point may have this as type 1 or type 1+2. The second point of distribution, should it be only type 2? And what is the permissible distance, or what is the experience distance, that within that distance, since we are using most of the armor cables, we can still go ahead with type 2, or we need not have a SPD at all? What is that permissible distance between the first distribution point or the entry point to the next distribution point? That's all.
So you said 2 questions, but you asked 1, 2, 3, 4, 5 questions.
Okay.
I'm happy about it. I'm really happy about it.
Yeah.
Thank you very much. Thanks for asking very relevant questions. In fact, and due to this short time today, everything will not be covered. But at the same time, this is always a possibility to discuss.
Yeah.
So first question regarding the 25 kiloampere, and let's see this, sir. You can see the screen here, right?
Yeah.
Good. So there are different systems, right? TT systems, DNS systems, the DNCS systems. I'm not going into the details of those systems now, but the only thing that we know, we have to understand here is like TT system or TNS system or even TNCS systems, where we have neutral and earth are not common actually, right? Where we have
TT, yes.
separate, yeah, where TT basically we have two separate earth also basically, right? But in TNCS system and TNS system, we have separate line, like we have the green and yellow conductor at our homes basically, which is connected to the body, and that goes straight away to the center point of or the main earthing bar, right? So that is for tripping of the ELCB and all that plays the role there, right? In case of any fault, then that is TNCS or TNS system. That depends upon the configuration and transformer that is used. So when we are using this 4 wire, basically the line neutral, and then 5th wire is for our earth that goes from the panels actually. We have to use the arresters in 3+1 circuit. Here you see 3+1 circuit. It is visible here. You see, sir, 3 between each line and one common point, right? And 1 between this common point and the earth. So this is 3+1 setup basically. If we use the 4+0 setup, because there are 4 lines only with respect to earth, right? Earth is itself is a line in our homes. Then in that case, we will use each arrestor here. First of all, you see here, each arrestor is connected between line and neutral here. And then neutral to earth. Neutral is the central point here, right? In 4+0 system, we will have earth as the central point, where all the arresters will be used from these lines extended to the earth, even neutral to the earth. Now, just imagine actually, when you are having a TT system where 2 separate earths are there, and one of these arrestor fails, which is connected between line and earth, it creates earth is nothing but our body, right? Body of the equipment, and it creates a short there. Then what will happen? The body will have this voltage which is there on the line. This will appear on the body of the equipment, and this will be dangerous for the human beings there. If somebody touches there, then it becomes a bigger issue. So when we connect these kind of arrestor from line to earth, then we also carry a risk of safety, which nobody wants to carry. So that is why this 3+1 circuit was devised, where the arrestor is connected between line to neutral, so that if there is a fault in the arrestor, if there is a short in the arrestor, line and neutral will be shorted, and because of this shorting, the MCBs or fuses will trip. So there will not be any safety, compromise when we connect the arrestor in this fashion. When we connect the arrestor between line and earth, there could be possibility of damage. Solution is we have to use the RCBs, ELCB with that kind of arrangement, but nobody uses it. But in the meanwhile, second thing, in India particularly, you asked me from the experience also. If you connect the arrestor between line and earth, because of very high varying voltages between line and earth, in TT system, and naturally it is going to be there, the arresters are bound to fail. The arrestor definitely fail there, and there are instances. I'm not going to say the makes here basically, but there are instances where even the arresters could caught fire. So this becomes very big safety issue if we connect between line to earth. It is always good to connect between line to neutral, so that you have a controlled short circuit whenever there is a failure, so that there is a tripping of the fuse or a MCB to bring it back to the safe line. I hope the first question is answered.
No, this was the second question, not the first question. This was the second question.
So second question, first question now.
Yeah, for second question is
second
answered.
question is answered, sir, right?
Yeah.
Now we go for this 25 kiloampere and 100 kiloampere.
Yes.
So you see here basically, let us say total lightning is 200 kiloampere. It will depend. It can be 200, it can be 50, it can be 150. Depends upon the area and geography and all other things. Just for example, if it is 200 kiloampere, which is the worst case actually, type 1 SPD, peak value of type 1 SPD is there. So then in that case, you have earth resistance. Let us say, or forget about even the earth resistance now. There is a 50-50 rule. Just follow that right now. 200 kiloampere 50% of that will go to the ground. That means 100 kiloampere approximately will go to the ground. Balance is 100 kiloampere. When you are using a 3+1 circuit, that means arrangement is like this. That is why I thought of explaining it first, why it is necessary to connect it like that. So this circuit will now decide how to divide the current. You see this resistor, the current is coming from this side, earth towards the line. So it is having the full current, 100 kiloampere, which is left out from the earth, right? So the arrestor which is connected between neutral to earth will have to be designed for 100 kiloampere. And after that only it is getting divided into 4 lines. One is the direct line to the neutral going to the center of the transformer. Other is through these 3 SPDs going from the lines and then the faces of the transformer, then to the center and then to the earth. So the division is in 4 lines, but out of these 4 lines, the arrestor above is in 3 lines. So every arrestor will carry 100 divided by 4, 25 kiloampere current, and rest 25 kiloampere current will go direct. And whereas this arrestor, which is connected between neutral to earth, will carry 100 kiloampere current. So that is the division of the current. If you could connect it between line to earth, then all the arrestor will connected to the same connection point, and then you have 100 divided by 4, 25 kiloampere each. If you use 4+0 system, but you are not using 4+0 system for the reasons now you know. So 3+1 system, 100 kiloampere and 25 kiloampere each.
Understood. Point is clear. Now, when we are ordering it out, suppose we are placing an order to some vendor, and in the order we just write 25K into 4 pole, or we write 100K. It is one and the same thing, I assume.
No, sir.
So it is understood that neutral to earth is 100K in all these cases.
No, sir. In fact, basically, please mention 3+1 circuit, line to neutral 25 kiloampere, 10 by 350, which I told you very importantly, and neutral to earth 100 kiloampere. One line, there is no
So
issue.
it has to be specified, all these things.
Specified.
If it is
Not
not
only that,
specified, then what is the assumption the manufacturer makes? Suppose we only specify 25K per pole, making it 100K. Then what is the assumption that the manufacturer will decide? Okay,
it
this is the
depends upon
combination.
the manufacturer. If you send it to us, then we will, see this as it is, as we know. But there are ways of playing in this. They can.
Sir, may I request you to cover all the answers in one-to-one conversation, because we will share the number. We should give chance to others to ask question.
Please.
Yeah. Okay, so Mr. Roda, should I go with other 2 questions also?
Yeah. We
Okay.
can take 2-3 questions one by one.
Okay. So there are 3 more questions from Mr. Mittal. Should I take 2?
Yeah. Kindly unmute one by one and ask your question.
Mr. Roda, shall I take the questions left out by Mr. Mittal right now or later? If the time.
Later, because we have to give chance to everyone to ask question.
Great. Fine.
Yeah, good evening, sir. Myself, Supradeep Ghosh, calling from West Bengal. Actually, I want to know that we are using different equipment such as start delta transformer, genset, and other electrical equipments, and as well as the electronics equipment. So there is a separate neutral earthing in transformer, and there is DG neutral earthing also through conductor. We are grounding, and body earthing is there, and separate electronics earthing, body earthing is there. So may I know that we can connect all the earth pits in grid, or we left the LA earthing should be separate? 2 separate earthings should be done with LA, and transformer neutral earthing should be always separate, not in grid.
Understood your point, sir. Thank you very much for the question. Rajeshi, you will like to answer it because you are a master of earthing.
Sir, I have made many videos and I always say one location, one earthing.
Yes,
you can refer my video to get the answer, and in that video I have given all the reference IC and IS also.
So it is always.
We can take another question.
Yeah.
Thank you. Thank you so much.
हेलो, गुड इवनिंग सर, राहुल गौर दिस साइड। सर इसमें ऐड करना चाहता हूँ कि जो इलेक्ट्रिकल अर्थिंग है, जो जनरेटर की अर्थिंग है और जो इलेक्ट्रॉनिक्स अर्थिंग है, उसको ग्रिड में कनेक्ट करने से पहले हम लोग डायरेक्टली कनेक्ट कर सकते हैं, एसपीडी के थ्रू कनेक्ट कर सकते हैं।
सर देखिए,
एसपीडी का रोल लाइटनिंग प्रोटेक्शन रिस्क असेसमेंट के बाद आता है, तभी आपको एलटी सिस्टम में लगाना है। डायरेक्टली ऐसा नहीं लगेगा आपको। फर्स्ट यू हैव टू डू द रिस्क असेसमेंट एज पर आईसी 62305 पार्ट 2। इफ यू फील you need that one, then you have to use that SPD in the LT system also.
ओके सर, हमको सिर्फ पैनल के इक्विपमेंट की जो पावर एंट्री है पैनल में, मेन पैनल में, वहां पर एसपीडी लगानी है, ग्रिड के में कोई नेसेसरी नहीं है।
नहीं।
ओके सर।
सर इसका देखिए, आपको जब आपने लाइटनिंग प्रोटेक्शन का अपना एनालिसिस किया है, रिस्क एनालिसिस किया है, तो उसमें आपकी एसपीडी की रिक्वायरमेंट वहां पे आ जाएगी, राइट। तो एसपीडी की जो रिक्वायरमेंट आएगी, तो आपको किस पैनल में कौन सी रेटिंग का लगाना है, उसमें रिस्क एनालिसिस, डिटेल रिस्क एनालिसिस में पता लग जाता है। तो अकॉर्डिंगली आपको ये एसपीडी लगाना होगा। जहाँ तक अर्थिंग की बात है, अर्थिंग में बेसिकली दो तरह की अर्थिंग है आपकी। एक तो बॉन्डेड अर्थिंग है जो आइडियल अर्थिंग है, दूसरा कई प्रोसेसेस में ये होता है जो कम्युनिकेशन प्रोसेसेस हैं आपकी, या ऑटोमेशन की प्रोसेस है, वहाँ पर सेम अर्थिंग से कनेक्ट करने के लिए कई बार मैन्युफैक्चरर मना कर देता है कि भाई हम सेम अर्थिंग से कनेक्ट नहीं करेंगे। बट अगर आप देखें तो बेसिकली लाइटनिंग प्रोटेक्शन के लिए या सर्ज प्रोटेक्शन के लिए आपको अर्थिंग सेम चाहिए। जैसे अरोड़ा साहब ने बोला कि बेसिकली अर्थिंग आपको सेम चाहिए, अर्थिंग कोई अलग नहीं हो सकती। तो एक स्पार्क गैप बीच में लगाया जाता है दोनों अर्थिंग के, जैसे हमने ये अरेस्टर लगाया है लाइन और न्यूट्रल के बीच में, वैसे ही स्पार्क गैप लगाया जाता है ताकि नॉर्मली ये आइसोलेटेड रहे, जब से सर्ज आए उसी समय ये कॉमन हो, बाकी नॉर्मल ऑपरेशन में ये आइसोलेटेड रहे। तो ये डिजाइन अर्थिंग का जो होगा बेसिकली डिपेंड्स अपॉन द एप्लीकेशन।
ओके सर,
बहुत बढ़िया बताया।
Good evening.
Can we start? Go to the next question. Kindly unmute.
Yes, Vikas ji, good evening.
Good evening to you, sir.
This is good session for me. Actually, I have one question regarding actually that SPD is. Yeah, hello. Hello. Hello.
Kindly continue.
Are you hearing me, ji?
Continue, please.
Yes, continue.
Yeah. Actually, in that SPD faulty, it will become, before it is healthy, it is in green position. SPD class B, class C, right? Okay, it is faulty, it will become to red color. So after that, we have to replace the SPD, right? Okay, my question is, we have to don't remove for that one, because is there any designing for that not removing, and again we have to use for that one, like MCB? It will trip and we will.
Like this, basically, like SPDs, you can remove the plug and you can retain the base there. But at the same,
Yes.
in case of MCB, you are removing the whole MCB. Never the plug like this.
No. Yeah, in case of fault, for suppose MCB trip, we have to on switch on the MCB. Okay, right. But in that SPD, it will is that faulty? It will become red. So we have to replace the SPD, right?
There are two parts. One is basically MCB when it trips. When it's basically fault in the system, not in the MCB actually, right? MCB
Yeah.
fault means it is not tripping, or it is become loose, or whatever basically has happened, is burnt off. So that is the fault in the MCB. If it is tripping, it is doing its work, and it is doing its work nicely, right? So once you correct the fault because of which it has, then it will not trip. Use it. Similarly, SPD, it will keep on taking the strike. So it has got limitation, basically something around 300 strikes. After that only basically it will be failed, and then you will get an indication on it. Once you get the indication, you replace it as you are replacing the MCB, but it is easier than MCB to replace it. Even though the failure of this SPD will be much less than the MCB, but the replacement wide is much easier.
And now we will take the last question. Any question?
Yes, sir. Good evening, sir.
Very good evening, sir.
Sir, my name is Naran from Odisha. So this is very, very good session and knowledgeable session. Thank you, sir. But I want to know on things that I have observed SPD are connected as per design, as per requirement, all are okay. But I observe that when lightning are happening, SPD are okay, but our some component are going to damage, मतलब SMPS controller or something are going to damage. तो क्या क्या रीजन हो सकता है सर इसका बीच में? क्या क्या चेक करना पड़ेगा? What need to check?
Sir, first of all, you have to check the design of the SPD because I mentioned about the coordination levels. You have to reduce the energy which is coming at the input to this level. So it is always better basically to give the full specification, and then only we can tell, because there are many criteria like whether the voltage selection is right or not, whether the energy selection is right or not. So if it is not, then SPD will act like a showpiece only. It will not work actually. You have to, that is why I always say go into the details. If you mention one or two parameters, then maybe you end up buying just a showpiece there. So it is good. Please explain. Please tell us what are your voltages at which you are working, and what equipment is this. Maybe if you can tell us the make, that will also be better. And one can design it. These are the things which need to be designed actually, not just. And also there is a requirement of the backup fuse. What kind of fuse are you using there? What kind of cables are you using there? So all these things need to be there actually to select the right protection system. Otherwise, protection system will be like showpiece, which we don't want you to have actually. So more parameters, more detailing, and right product.
Rightly said. Rightly said. Beautiful answer. And now time to say thank you to Vikas sir. Dr. Vikas, thank you very much for sparing your valuable times, and you have given a mindful, a mind-blowing presentation in short, I can say. And I would love to request on behalf of all the participants, we can make one white paper on all the questions asked by the person, and we can distribute that white paper to all the participants who participated today. This is my request, and thank you once again for accepting the invitation. And that was great session, and many people have definitely learned many things from that session. And after that white paper, many doubts will be cleared, and we can have one-to-one conversation with NK Mittal sir also, because he has asked 7 questions and we could answer 2. The 5 questions can be.
I asked only 5.
Okay. 5. The left out 3 questions will be answered.
Okay, fine. That's okay.
So what I will do, I will just mention my number in the chat here. Basically, if you can just.
I'll take it from Rajesh. Rajesh is a friend.
No issue. Otherwise, what I will do, I will make a white paper of all the questions asked by all the participants, and we will distribute after that.
Yeah,
fantastic.
Rajesh
with proper diagram that will be answered.
Absolutely, Rajesh.
Am I right, sir?
Just to add one line in the end.
Please.
We are ending. This was really very educative. Number 1. Number 2. The way it has been explained in a simplified fashion in the slide, it makes it far more simpler and for people to understand. That is the first thing. Number 2, from the utility point of view, this is the application that surge protection is required. This is how to be used. Can we take some case studies and put it in your replies, or that?
For sure.
You have very, very varied applications, multi-storied building, 20 story, how it is repeated, when it is repeated. I'm using an armored cable, I'm using a non-armored cable. In case of a non-armored cable, whether I have to repeatedly use after some distance. If I'm using armored, maybe I can increase the distance. So there are so many applications that arises when you start working physically on a project. So this is just one example, but there are many applications that normally comes. So
then I request Almadi Sahab, kindly include that case study possible in that white paper. That is going to help many people.
Absolutely.
Kind of booklet.
I will definitely do that, sir. In the meanwhile, I request all to please visit DEN website and go for this book, Lightning Protection Guide. Actually, this is very useful book for all. Please download it from there. Many of the answers we will get there, but myself and Rajesh will write a paper which will be based on the Indian applications, and it will be really easy to understand for all.
And with that, thank you everyone. Thank you everyone for spending your time and patience listening. Thank you once again.
Okay.
Thank you, Ajay.
Thanks a lot, everybody. Thanks a lot.
Bye.
Thank you.
Salute to everybody.
Bye, sir. Thank you.
Thank you, sir.
Thank you, Saket ji. Thank you once again.
Thank you
Thank
very
you,
much,
sir. Thank you.
everyone. Thanks,
Thank
Rakesh,
you.
Rajesh, and thanks everyone in the IPE also. Thank you.
Thank you.